We're going to look at how, if you have a shape in the coordinate plane, if you could show that it's a parallelogram or one of our special parallelograms or a trapezoid or a kite or one of those things. So if we go back and we take a look at our theorems that we have, first we want to look and see what a parallelogram is. So we can use the definition that the parallelogram has two pairs of parallel sides. We could also use any one of these to show that it's a parallelogram. So in the coordinate plane, we could show opposite sides are congruent. We don't have a way to show angles are congruent unless they happen to be perpendicular. But then you would show that the slopes are opposite reciprocals. You could show that the diagonals bisect each other, but you would first have to find the midpoint of each line and then show that this distance is the same as this distance, which is the same as this distance, which is the same as this distance. So you're doing 4 distance formulas and 2 midpoint formulas, as opposed to just showing slope, 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 slope. So I think that's more. Again, we don't have a way to do angles. We could also just show that if they have a pair of parallel and congruent sides, then that means that it's a parallelogram. If we're doing a special parallelogram, we have our pieces of information here. So we could use these corollaries to show that that the parallelogram is that special parallelogram. But you already need to know that it's a parallelogram. So we need one of these up here first, and then additionally, we need one of these, right? So you need either one of the corollaries or one of your theorems with it. So with a rhombus, you could show that the diagonals are perpendicular, or you could show that all 4 sides are congruent, or the diagonals bisecting the angles wouldn't be able to be shown on a coordinate plane. So this one's out. If you're looking at the diagonals being perpendicular, you would have to show that these are parallel and congruent, or you could do these are parallel and then these are parallel. And then if you're showing that it's a rhombus, you would have to find the slopes of these two as well. If you're showing that they are congruent sides, you can use the information that you used for your slope to get to the distances of the sides. So I think that's easier. So let me show you some examples. So if we want to prove that FGHJ is a parallelogram, we could choose to show that these are parallel and these are parallel. To show that they're parallel in a coordinate plane, you would have to find the slope of all 4 of these and then show that these match and these match, GH and FJ match, and then that would show that it's a parallelogram. We could also choose to show that GH and FG have the same slope, but they also have the same distance, and then that makes it a parallelogram as well. So GH, the slope of GH is pretty quick to find because of the fact that it's a horizontal line, so we know that the slope is 0. The slope of FJ would be the same thing. It's really quick to find because it's, again, a horizontal line, so you can get quickly that the slope is 0. So then you already know that these are parallel since the slopes are matching. That leads us to find the slopes of these. So we could find the slope using our points, or we could use counting on the graph. So we go over 1 and up 1, 2, 3. So left 1 and up 3, left 1 gives us a positive 3 over a negative 1, which is a negative 3. And that is the slope of GF. And then if we look at the slope of HJ, we've got up 1, 2, 3, and left 1. So the same kind of thing. So slope of HJ was up 3 and left 1, so positive 3 over negative 1, which is negative 3. So because these are parallel, or the same, then we know that they're parallel. So we've got this set of parallel lines and this set of parallel lines. So that means that it's a parallelogram because we've got our 2 pairs of parallel sides. Okay. I could have chosen to find this distance formula for GH and FJ and show that they are the same, or I could have chose to show the distance formula for GF and HJ and show that those were parallel and the same, and then that would have been enough information as well. Okay. So in order to show that it's a rhombus, we have to show that it's a parallelogram and either that 4 sides are congruent, to make it a rhombus, or that the diagonals are perpendicular. That would be another way that we could show that. So we have the option of, since we have to show it's a parallelogram, I either need, I need these being parallel and these being parallel, so the slope's the same, or I could do these parallel and the same distance, which would lead me to find just the distance formula of this one. If I do the slopes of all 4 of these, it helps me get to the distance formula. So let me show you what I'm talking about when we do that. So if we look at the slope of CA, and we've got our letters here, so I'm going to use, well, they are letters, but we have the points listed with the letters. So I'm going to use y minus y over x minus x. So our slope of CA is going to be 6 minus 2 over 0 minus a minus 1. So then that gives us 4 over 1, which is 4. If I find the slope of ST, that's going to be, I'm looking at y minus y, so 3 minus 7, over x minus x, so 3 minus 4. So this will be negative 4 over negative 1, which is a positive 4. So these are parallel. So now we've got one set of parallel lines. Well, if I look at AS, okay, when I'm looking at AS, I'm looking at these two, so I can do y minus y over x minus x, so 7 minus 6 over 4 minus 0, so this is 1/4. And then if we do the slope of CT, so I'm using these two, so 3 minus 2 over 3, what letter am I doing? 3 minus a minus 1. So 3 plus 1, so then that gives me 1 over 4. So notice these are the same, so they are parallel. Okay, so now I've proved that it's a parallelogram, but we want a rhombus. A rhombus, you could do that the 4 sides are congruent, or you could show that their diagonals are perpendicular as well. I'm going to show that their 4 sides are congruent. So what I'm going to do is I'm going to use my slope to get there. Remember that our distance formula is really y, well, I think we start with x, but it doesn't actually matter. x2 minus x1 quantity squared plus y2 minus y1 quantity squared. But this is the top portion of the slope formula, and this is the bottom portion of the slope formula. So what I'm going to do is I'm going to take these numbers here and put them into my distance formula. So I'm going to take the 4 and square it, and then I'm going to take the 1 and square it. So then that just gives us 16 plus 1, which is the square root of 17. So now I know that the distance of CA is root 17. So if I check the distance of ST, okay, we can quickly get that we've got from here, this is negative 4 squared, and then from here, we take the negative 1, so that gives us 16 plus 1, which is still the square root of 17, so those are the same. Now I need to check, excuse me, these over here as well. If I do a quick check, I can see that that will get me the same thing, because notice we have the same here on each of those that we had in here, right? So if we take our formula for AS, it's going to be 1 squared plus 4 squared, which is root 17. If we take CT, that's going to be 1 squared plus 4 squared, which gives us root 17. So because we know that CA equals AS equals ST, which equals CT, then we know that the parallelogram cast is a rhombus. Okay. So we used this slope information to help us to get to the distance formula, which makes it slightly quicker. Okay. If we look here, we've got determine what the most precise name for the quadrilateral with the vertices L, O, V, E are in those. So I already plotted it here. So to me, this looks like a square, but we don't go by looks in math when we're proving things. So I need to show that it's a square. Well, if it's a square, that means it's a rectangle, it's a rhombus, and it's a parallelogram. So if it's a rectangle, we need to show that these are perpendicular, these are perpendicular, these are perpendicular, and these are perpendicular. Well, to show perpendicularity, you show that their slopes are opposite reciprocals. But we have to show it's a parallelogram first, which means I need to show those slopes match and these slopes match. So I really need the slopes of all four of those, and it will help me get to the fact that they are parallel and then also perpendicular with different things. So parallel to these ones, and then this would be perpendicular to those two, and this would be perpendicular to those two. So I'm going to find the slope for all four of those. So if we do the slope for LO, okay, we're going to do 2 minus 5 over 5 minus 2. So that gives us negative 3 over 3, which gives us negative 1. You may prefer to be counting. It's a little small here, so I like to use my vertices that I already have, but I do need at least your slope to show that you understand how the slopes relate to showing that this is for sure whatever shape you're trying to prove. So we've got the slope of VE, I'm going to do next so that I can show that they're parallel. So we're going to do negative 1 minus 2 over 2 minus a minus 1. So negative 3 over 3, which gives us negative 1. So I now know that these are parallel. So now I'm going to find the slope of the VO. So then 2 minus 5 over negative 1 minus 2. So negative 3 over negative 3, which gives us a positive 1. And then I'm going to find the slope of EL. So the slope of EL is 2 minus a minus 1, so plus. And then 5 minus 2, which gives us 3 over 3, which is 1. Right? So now we know that these are parallel. So we've got that's parallel and that's parallel. So then I know that this is for sure a parallelogram. Well, it's looking like a square to me, so I need to check and see if they are perpendicular. Well, to check and see if these are perpendicular, I need to check and see that these are opposite reciprocals, right? Those are opposite reciprocals. So we're looking at LO and VO, and then with EC. So we're checking to see if these are perpendicular, then that means that those are right angles. So if I look here, we've got 1 and negative 1. So these are opposite reciprocals. So these are perpendicular, which means that now I know it's at least a rectangle. Well, it also looks like it's a square to me. If it's a square, that means it has to be a rhombus. So in order to show that it's a rhombus, I need all four sides congruent. So the distance of LO is going to be, again, I'm using my slope, so this would be negative 3 squared plus 3 squared, which is 9 plus 9, which is root 18. I can break that down to 9 and 2, so that gives me 3 root 2. If I do VE, notice I'm plugging in the same thing here. So this gives me 9 plus 9, which gives me the square root of 18, which we know is 3 root 2. If I check the VO, what's going to be the square root of negative 3 squared plus negative 3 squared, which gives me 9 plus 9, which is still root 18, which is still 3 root 2. And if I do EC, it's close to the last one, but it's not the same, right? But because of how you're squaring negative numbers, it will end up giving you the same 3 root 2. So all sides are congruent. So this means that the most precise name is a square. Okay. But when we're asking for the most precise name, you need to show your reasoning behind how you decided what it was. Okay. So here, this one's asking if we want to know if it's a kite. Well, remember the definition for a kite is that you have that these consecutive, no, not what I wanted to say. The consecutive, you have two pairs of consecutive congruent sides. So these two look like they're the same and these two look like the same. We do have a theorem that says if it's a kite, then you know the diagonals are perpendicular, but we would have to know it's a kite first. So I can't just show that these diagonals are perpendicular. I would have to show that those four are congruent. So that means, not 4 congruent. These two are congruent, and then these two are congruent. So I'm going to check and see, are AT the same as TE? And we need to show that AM is the same as ME. So if I check the distance of AT, so here we don't have a slope to go off already. So I'm just going to do my subtracting x's, subtracting y's, and squaring both of them. So here I'm looking at these two to help me get there. So I'm going to do 4 minus a minus 3 squared and 5 minus 3 squared. And that was AT that we're doing. So then that gives me 7 squared plus 2 squared, which is 49 plus 4, which gives me root 53. Then I'm going to check TE. So I'm using this and this. So I'm going to do x minus x. So 6 minus 4 squared plus negative 2 minus 5 squared, which gives me 2 squared plus negative 7 squared, which gives me 4 plus 49, which is still root 53, right? So that's great. We've shown this. Now I need to show that AM is the same as ME. So AM, I would do negative 13 minus 3 squared and negative 6 minus minus 3 squared, square rooted. That was AM. So then this gives me negative 16 squared plus negative 3 squared. So if we square that, when we square 16, that gives us 256 and 9. So when we add those together, that gives us 265. All right, and we shouldn't be alarmed because we're not trying to match it to the next one. This is 5 times 53. I don't need to break it down at all. I just need to check and see, is it the same as ME? So now I'm going to check ME with my distance formula. So I'm going to do 6 minus a minus 6, which is plus, and then negative 13 minus a minus 2, so plus 2 squared. So that gives me 12 squared plus negative 11 squared. Negative 6 minus a minus 6, negative 13 minus a minus. So that gives us 144 plus 121, which gives us 265 as well. Nice. So because we know that we have 2 pairs of congruent consecutive sides, then we know that it's a kite. Okay. Now for a trapezoid, in order for it to be a trapezoid, we only need 1 pair of parallel sides. So I've already drawn this as well. So these look to be parallel, so I want to check and see if those are parallel. And then we want to check and see if it's an isosceles trapezoid. So if it's an isosceles trapezoid, I want to check to see if those are congruent. They look congruent, but we need to check and see. So I need the slope of IS. So if we do IS, that's going to be 4 minus 4. Oh, it's also very easy, but we'll just continue this. 4 minus 4 over 5 minus 0. So this gives us 0 over 5, which is 0, which I could have told you from here, or from the graph, because it's a horizontal line. So our slope of RE is 0, so then that means that these are parallel. So we've got our one set of parallel sides. Okay. These are obviously not parallel because of the fact that this has a positive slope and this has a negative slope, so they cannot be the same. So we've cut out that it's not a parallelogram. But I do need to check and see if RI is congruent to SE to check and see, is it an isosceles, because that's what would make it an isosceles trapezoid. So if I check my distance formula for RI, I'm going to do 4 minus 0 squared. I started with the y's on this one. And 0 minus a minus 2 squared. So that's 4 squared plus 2 squared, square rooted. So 16 plus 4, which gives us root 20. That's 4 and 5, that's 2 and 2, so that gives us 2 root 5. So now I need to check SE. So if we check SE, oh, there's no E, that's totally okay. Try 2. ISRK. Sorry. SK. Okay, I just randomly turned a K into an E. Sorry about that. So now we're checking SK since I randomly decided to change letters. Don't do that. It's not a good pun. We're going to do 4 minus 0 squared plus 8 minus 5 quantity squared. Let's make sure I got the right letters now. S and K. 4 minus 0, 8 minus 5. Yeah, so 4 squared plus 3 squared gives us 12 plus 9, which gives us 21. So it is not an isosceles trapezoid. So they're close, right? This is the square root of 20 and this is the square root of 21, but they are not the same. So this is just an isosceles trapezoid. Okay. So you're using either theorems that we've had before to show that something is a trapezoid, or that it's a particular quadrilateral shape that we've been looking at in the coordinate plane, using our slopes to show if they're parallel or perpendicular, and using our distance formulas to show if you have congruent parts.